Hello everyone, my name is Dr. Turngo Anderson Gadget. You can also call me Turngo or Dr. Turn. Uh, Today is going to be an exciting one. In the last recording, we did, let me stop this cam real quick. We did the predictions that included their interaction terms. Uh, this was where we left off. We flattened the one, the 2D to 1D, went ahead and bring in, change that to the data frame. And then we, compare the actual values with the predicted values, and these are the differences. Today, we will go ahead and we will evaluate this model. And let me scroll up. In the last regression that we did, in the previous regression that we did, that we only use the four variables, which was for insulin. The insulin was a criterion variable. Let me see if I can show you the table. Good. We only had these as the variables: age, gender, BMI, and insulin was a predictor variable, right? So which is up here. Let me scroll up. Let me just scroll up and show you. Perfect. So this age, gender, BMI, and insulin with the predictor variables, right? So these are them here. So these were the predictor variables, and then this was the criterion variable. Now we did the regression. I'm just going over a quick overview so that you understand what we're going to be doing next. After we did that, we predicted the values here, and then we used these metrics for performance evaluation, the model performance evaluation. In this recording that we are doing today, we will add more metrics. We will be adding the metrics that we will be doing will be mean absolute error, mean absolute percentage error, symmetric mean absolute percentage error, mean squared error, rooted mean square error, and R square, as well as the adjusted R squared. This will help us, all of these seven, I think about seven of them, will help us to evaluate this model. And then we'll compare it with the other, with the previous our model. So let's get on with it. So let me see. I'll just go here, evaluate. I think we'll just say three-way moderation, three-way moderation model. Okay. Uh, right. First, we say compute mean absolute error. MAE. Again, I did that up there in the previous video. I did this. That will be. Let me run this all first. When I'm done, I will have to hit run all so that the libraries that I imported. Let me scroll the way up to show you. Earlier, we also import to be sure. So these are the matrices that are included up here. Here. So I have 1, 2, 3, 4. I will be adding more as we go. So let me scroll all the way back to the bottom. Then let's continue. Okay, so MAE is equal to mean absolute error y test y pred. This one here, very important, because Next, I would say z. Copy that. Let's down here. I will say mean symmetric mean absolute error. Okay, so that should be that. Here, before I do that, I'm gonna have to come up here and add this. I'll have to update this my file here, my libraries, my the packages that I imported here. So let me come in here, and then I'll add mean, or let me just say symmetric mean absolute error. Then come down here. I'm scrolling too fast, sorry guys. Before that, I need to add one more here. I'll say add that. Compute mean percentage error. Mean absolute percentage error. Because it's make. So we'll say map is equals to mean absolute error times 100, because it's a percentage that we're using now. So let me just run this just a test. Let me hit run all. Oh no, not you. Run all. So that to also update the libraries up there. Okay. Okay, that looks good. So now we're gonna have to run the symmetric. So define y actual y pred. Let me see if I already have y actual here. Where y. Let me pause this video and finish this code because it's going to be a long one. Okay. Where y actual, because I already typed. Let me see y pred. I already typed y pred, so some prediction should be coming up. Is numpy array y actual numpy array y pred that, such that the denominator should be absolute value y actual plus value, sorry, of ypred. All of that divided by 2. Let's map val to np mean ypred minus y actual, yes, y actual, divided by denominator. Let me just copy that and paste to avoid typo issues and errors. And then all of that, multiply that with 100. Return let me just add 3WM here, three-way moderation, all in lower caps, just to help me. Okay, now let's run that and see if it works. So let's see. Okay. So npy array ypred okay, I think I forgot to add a comma here. That's why it's telling me that. So let's add a comma there. And run that. Okay, no more error. Okay, that is good. Next, we will compute our. We're done with that. So let's go back. Compute mean squared error. This video may be kind of long, so because this is evaluation, this is perhaps the most important part of this session. Mean squared error, but it is worth it. Here I will just copy this here and paste it down here. Next, compute root mean square error. RMSE. So RMSE, did I? Yes, I think it's already in there. That will be numpy. Because we're just getting the square root of that. Yep. Next, we'll compute r square. Okay, score. That's R2 should be to score Now the second one is in order. And then y test, just copy that here. Good. Next we will go with, so we got 1, 2, 3, 4, 5, 6, 7. The last one is adjusted r square. Adjusted r square. Let me just change that calculation. They will say that n is equals to 1, n is 1, length y one minus, so this is just the computation for adjusted r square. Okay, that will help us multiply by 1, divide that by that. Okay, now we're, let's see, learn that, learn. There's no need for a 1 there. So n should be equals to that. Where did that one come from? Let's see. And equals to that. Let's see. So value y actual is not defined. Okay, let's see. Y actual. Copy that here. Okay, so y actual is not defined. Let's see what's going on here. Oh, okay. I think. I think this should be y test. Duh. That took me a minute to find. Okay, so let's see. Okay, now that should work. Okay, now now we're gonna have to view this. We'll run this. Recall how up here we did that, but nothing came out. We're gonna have to write something like this. Let me just copy this as here as well. I might as well do that, and then paste it down here for it to print out. So let me just show you an example. If I do this, if I run that here now, see how it came out? But I'm gonna have to do the same for symmetric mean, absolute error, and the rest. So let me go ahead and do that. Let me pause this video and do that, and then I'll be right back. Okay, so we're back. So let me just make sure that I type everything right. Let me just run it first. Okay. So y actual is not defined again. Again, this y actual keeps coming up instead of y test. Oh no. Okay, that's good. So let's do that again. Okay. Okay, let's fix that. Ypred underscore 3, because you see that's what we have up here. Run that. Let's see. Let's check here. Oh, I see what's going on here. That. And that. Let me see. I hope it's what I'm looking at. Okay, let me just check this out and see first. Hang on, let me just do that and see. Okay, everything else came out. So that's 1, 2, 3, 4, 5, 6. So that's the only place that error is coming from. Okay, that will be an easy fix. So let's try and fix that. Give me back the error. Okay. Okay, so it says here that module numpy does not have any record AB. So that means I'm supposed to type ABS for absolute value. So somewhere maybe I forgot to type that here. So let's see. Let's go up there. Oh, maybe that is it. Maybe that's why. So let's run that again and see. Yes, it works. Okay, so wow, it's amazing how one later, if you miss it, you can throw off. So now this is the model performance. We have mean absolute error of 4.95. That means that about 4.958 units deviate away from the actual mean values. Then we have the this is too a bit high, 495%. That's really high. Something is not right here. I will check that. And then we have a symmetric mean absolute percentage error of 44.7%. This is high. Both of these two are very high. That means that this model, well, could be again, like I said earlier, it's low to moderate. I'm gonna jump down here and come down here. The squared R squared error is 38%, as well as the adjusted square. So that means that this model accounted for 38% of the variability in the criterion variable, which is the insulin. For this one, mean absolute error percentage is kind of like high. Let me check if the calculation is off somewhere. But it looks right. Okay, so it looks okay. So this is how we do the model performance for interactive terms. In our next video, we're going to be comparing this. I will add this, some of the items I added up here to the model up here, and then we will compare them. In other words, we'll compare the 7 of these matrices, 2 of these metrics with the other multiple regression that we did. Thank you and have a nice day. Bye.